Welcome, everybody. Today is the 25th of July with Dallas Personal Robot Group, Builders Night Virtual. And we're going to do the usual thing, what we do, and go around the table and talk about projects and questions and mostly robot-y things, but occasional detours. So far in queue, we have Doug D., I think with a steampunk RoboDog update, and then Dave Ackley, the I2C kind of thing, and then returning DPRG member Ed to share a bunch of projects, and then open mic. So with that, Doug D., take us back to the steampunk days.
Okay, so if you pin me, you might get a better view. I'm not going to present. I've got the tablet down on the floor, so you should be looking at the robot here. I haven't put the head on it yet, and I finally got the motors wired up, and I can make it spin in a circle. So prepare to be wowed. A little pause.
Oh.
Is it still on camera?
Yeah.
Yep. That's nice. All right now. I think
very nice.
Yeah. Gold star.
Yep, gold star.
Yeah. So could be stop it here. It killed itself. Okay. So that was that. And this is now. I'm pretty excited about it. Whoa.
Yeah. Should be.
Good.
Very nice, Doug.
Yep. Thanks.
Hey everyone, I'm Naveen. I just joined this group, so I don't know what is the decorum here. But is it okay to ask some questions to Doug? I'm very new to the robotics and.
Yeah, Naveen, pleased to meet you. So what we do is we go around the table usually.
Okay.
We start off with a cue, and then we get to an open mic night. So if you don't mind, was just finishing a presentation on his steampunk RoboDog.
Yeah.
And then Dave Ackley has an update. Ed has an update, and then we can put you in the queue if you'd like. And
yeah,
I think he wanted to ask Doug some questions. Is that right?
But I can wait. Yeah, that is right. I just want to ask some questions. I'm learning robotics. It's my brand new me, but I can wait. Yeah, please go ahead with your presentation.
You can ask questions.
I'm overloading.
Yeah, your microphone is really, really hot right now. If you could mute, not tamp it down a little bit.
For me? Okay.
Yeah, it's very, very loud. It's blowing out. But you can ask questions right after somebody's presented. That's not.
Oh yeah. I mean, normally we interrupt each other, but we try and give them a floor enough to tell their story before the detours begin.
Okay. Yeah. I'll wait. Is this better or still my voice is
still a bit hot?
Oh, okay.
Still a bit loud.
Let me try a different browser then. But yeah, I don't want to hold you up on this. Please continue.
Okay,
Were you done, Doug?
Yeah, that's it. I just was going to show it. Actually, motor's running now.
It's a good deal.
So go ahead.
You're still on track for, what is it, the December convention?
I hope so. It's supposed to be ready for a live demo in November, but I think I can make that, and then the real thing's in December. I have to put the head on and hook up the camera and the sensors that's going to be in the head, and then I have to change the programming. Oh, I did have one more thing. Not specifically related to robots, although tangentially. See this?
Black box.
Yeah, black box about the size of a paperback book. It's a full Windows computer. Ooh. I got this for my astronomy. It's a Windows 11 full computer, and I can control it with VNC like I did the telepresence robot. So this in the future will be the brains of one of my robots. Now, it was about $160, gone up to $200 since Amazon Prime. They do have cheaper ones. It's in my mind, can be a replacement for the Raspberry Pi as the AI of the robot, because Raspberry Pis have gotten so expensive, they're in the same price range now. So just FYI, you may see this controlling something in the future.
What kind of processor does it have?
I don't remember exactly. I'm trying to remember, something 6000. It's not an ARM chip. It's a full chip, but it's a mobile type chip.
Is it a Celeron?
I don't think it's a Celeron. Let me see if I can bring up the specs on it real quick.
Oh,
Yeah.
man, maybe an AMD processor.
So let me present real quick before I move on to the next person. You should see my more fine screen now. It's an Intel, forget coupons, it's an Intel 11th generation N6000 on this one. They've dropped back down. It was 200 and something last week. Now it's 189 again. It seems to move around. Their competitors in the 130 range, and you can get cheaper ones than I got with less memory.
Doug, can you put that link in or
Put that in the chat.
yeah? Oh, iShop.
So I can stop looking at this now and stop presenting. If you go to Amazon and look around at that, you can see or other things that are, they actually have some that are stick computers supposedly plug into a USB port. But since I'm a Windows programmer, not a Python programmer, I'm excited about being able to program in my native language for the AI part.
Doug, what type of ports does it have? I didn't see on the. What's sticking out of it?
There's 3 USB ports. I think 2 of them are USB 3 and one's a USB 2.
Hold it up a little bit higher. Right? We didn't. Oh, okay.
Maybe I can get more light on it in this direction. If I unplug that.
Yeah, there you go. So it's got
3 USB ports. It's got a Ethernet, and I'm not quite sure what some of those others are because they're facing away from me.
Yeah, one of them's HTML, I think.
Right, HDMI.
Yeah, and then the other 2 look like they're USB-Cs.
Yeah, there's a USB-C power port, and it takes 12 volts, which is a little bit of an issue that I have to solve to get the mobility part of it working, because I've got a number of 12-volt battery systems, but I don't have a plug that plugs into the USB that comes from my batteries. I got to buy a cable, and I think I've got one over there somewhere that has a USB end to the USB-C end, and that'll make it so that I can run off the battery.
Yeah.
I think also, I think SparkFun has some USB-C power delivery boards.
Right.
That you can just hook up a big 12-volt anything power supply to, and so then you could have even more variability if you wanted to.
Yeah, I've got some USB, not USB, some powered changing boards. I forget what you call them now, where it brings my 18-volt Ryobi down to 12 volts to make it run.
Like a buck converter.
Ryobi as part of, although I've got the Ryobi and the RoboDog, so it depends on what I want to do. The other thing I got was this, which may not be visible because it doesn't have long cords in it, but it's a mini wireless router that I expect will give me the ability, without being attached to the internet, just to have the robot and my phone attached to this, and then in the streets of Galveston, when I'm rolling down the street, I can be connected to the robot with my telephone, and I can put it on my arm like I was planning it on. I can go ping, 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 and make it move. So I'm pretty excited about things that are coming together there.
I would warn you against the Wi-Fi connections. We had bad experience with Wi-Fi being so overloaded one couldn't even get even a small message through.
Yeah, I am concerned about that, but I think since I won't be on the internet, I will be the only one loading it, is what I'm hoping. I'm going to test it. We'll see.
Test it in a busy place.
There's a big difference between testing it at home and in an open environment versus at a big convention that we discovered they were impossible.
Right.
You may look at creating the access point from the robot perspective.
Right.
That way you'll have your own private Wi-Fi, and you won't have any bandwidth issues.
Right. There's a way to do that in Raspberry, and I've tagged the spot, but I haven't tried it yet.
Yeah, that's how I actually the way I develop on a Pi is through wireless SSH connection.
Right.
And part of the problem with Pis is you can't get them to create a static address, right? Especially if you're trying to get them on your router, right? Because it's going to assign those addresses. So if you turn that around and create the access point on the Pi, then you basically take your network and connect to it, right? Or I usually keep it a private between machine, but because it's just an access point. But
exactly, that avoids all the bandwidth problems of everybody.
I mean, we've seen a lot of. I think Carl one time had this huge Wi-Fi set up at Makerspace, and he couldn't get it connected. I don't think you could get it on. I don't know, Carl, if you remember that.
I don't. Yeah, there's no doubt about it. It was one of these. It was probably this one, a nice little Asus MIMO, and they called it the Black Knight, and it did great, except for when you got into 802.11b 2.4 in the Makerspace environment, and whatever dongle client was on the robot at the time, they just could not hold any kind of connection at all.
Huh.
It had nothing to do with the internet. It had everything to do with the RF link from here to the robot.
Interesting. So I may have more trouble than I expect.
Yeah, that's the part if you want to check it, you want to, I think you want to get to a place where there's lots and lots of phones and lots and lots of Wi-Fi access points, because that's where they fight one another.
Right.
Yeah, Carl and I can attest to the fact that in a wild environment where there's lots of phones and other Wi-Fi stuff, there is no way to get any access.
Okay. Well, RoboDog's going to have to go out in the public and find himself a busy spot.
Find a busy spot with all kinds of Wi-Fi around him.
Yeah. So with that being said, I will turn over my time.
In fact, I think one of the Olympics had a robot
was going to be RoboDog
to do stuff, and they couldn't control it because the Wi-Fi didn't work.
Oh, that's right. Yeah, the recent Olympics had the exact same problem.
Well, if it wasn't for problems, we would have it all done.
Has anyone tried like the NRF radios in those places?
Well, personally, I want Wi-Fi because then I can use VNC. That's why I'm not using Bluetooth and other methodologies. But there are other things to do, of course. I just find VNC very easy. I can put the UI on the Pi and control it from my phone.
Well, one thing that may help you, Doug, is if you can, when you try the Wi-Fi in a crowded space, is to go do 5 gig instead of 2.4.
Yeah.
And maybe a good place to try it is the makerspace on a weekend.
Yeah. We can have a live demo down there just before I try to take it somewhere else, or even before that, if I get it functioning good enough.
Yeah.
The other
Everybody
one I've
can
heard is
touch it.
people change the channel on their Wi-Fi as well. If you're using it as an access point, change the channel that it's communicating,
Yeah.
and you may have luck with that as well.
Why?
I think they pick up, depending on the country, on a standard a channel that's pre-selected.
They're spread spectrum, so they share bandwidth. So it's a party line basically, and when the signals can't get through, they all tend to shout louder, just like you do at a party. So pretty soon everybody's shouting and nobody can hear anything.
Yep.
So and there are, like, for any given country, there's 8 or 11 kind of different channels. But some of them are more compatible to others than others. And then there's different combinations. So, and then some of the different versions of the codecs, the older ones and the newer ones, don't behave so well together. So it turns out that I think for US on 2.4, it used to be that to make the way the specs were written, the air interface, you would want to have it so that everybody was using either channel 1, 6, or 11. Because that gave the intermediate channels as kind of like guard bands. And as long as everybody was lined up like that on the same channels, then the protocols could detect each other trying to use the same channel, and they could negotiate the use of the spectrum most efficiently. But what would happen is that some of these automatic algorithms, like Pat mentioned, or sometimes people, would go and pick these intermediate channels, and then they'd pick one of the bandwidth modes that spreads across 3 and 4 channels at once. And because they did that, I don't know if it worked for them or not, but it would wind up throwing nothing but noise in the adjacent channels. Wind up with these devices just bollocksing up the spectrum, and it just came to a screeching halt.
Wow.
And I don't know for a fact that 5 gigahertz is any different in certain regards, but from what I've seen in practice, 5 or 6 years ago, it used to be a lot less crowded than the 2.4. And I suspect, from what I also saw, I used to play around with some of the air interface sniffer tools that you could get, and they were showing that when I was trying to run the latest standard, there were still people out there that had, like, at that time, original standard Wi-Fi. So what that meant is that the older one just bogged down the newer one. So it was like the weakest link in the chain, and they just did not. Well, there's just so many standards, and they sort of work together, but it was, I don't know.
Yeah.
You're best off to try it in a very dense environment, and I would stick to the 5. Actually, I'll tell you, so Ray and I, we tried to do one of the maker fairs over at the Fort Worth Science Museum. And so we set up our robots, and they both, I don't know if yours used Wi-Fi or not, Ray, but mine sure did.
Yeah,
it worked fine until the crowd showed up. As soon as the crowd showed up, I couldn't get any connection. I mean, with that access point 5 feet apart, I couldn't get any connection. It would just drop.
Interesting.
Finally, after 2 hours of putzing around with it, I did the funniest thing. I said, well, we got nothing better. I can't show anything, nothing better to do. So I took that fancy whiz-bang access point offline. I set it aside, and I got a little travel one. It's looking a little more like the one that you showed us there. And it was only this one up there I showed you is dual band MIMO, all this fancy stuff. So I got out this old school original 802.11, old standards, single band 2.4, and it worked like a hose for 2 hours straight. I ran the battery down. It just worked. It never dropped. So that could be another thing if you force it right to the 5 gigahertz or force it down to the least common denominator, the really old specs.
So, Carl, is the issue with the location where the router is placed and the crowd blocking the waves, or is it just the specs of the router?
It was, well, I think from what my understanding or guesses, it was the idea that router could not handle channel congestion.
Okay.
A couple of hundred phones showed up.
It was the number of transmitting devices, just, balloons when you go to big events. We have to deal with that a lot also, right? Because all of our robots are Wi-Fi based, and it's, our control scheme is completely reliant on it. So they have very strict controls over channel assignments and things like that. And we've almost all moved to 5 gigahertz also because, it has, if you think of 802.11b as having like 3 non-overlapping channels, it has more, but 3 non-overlapping channels, then 5 gigahertz has 24. So there's just more spectrum there, and not everybody's switched over to it yet. But although it's starting to get more congested now.
I have a follow-up question. Stop me if I'm digressing too much, but if I have my own private Wi-Fi for any event and I have like a swarm of robots, would that still be a problem? I mean, only the robots and my software will connect to the Wi-Fi, and no other device will be. Yeah, would that still be a problem, or?
Because they're still using the same radio channels.
Okay.
I mean,
we're not necessarily talking about the internet uplink here. We're talking about just, point-to-point, device-to-device communication in a congested environment. It can get tricky.
Basically, everybody is transmitting on the same frequencies and jamming everybody up. Think of it as a big jamming, RF jamming session.
Even Bluetooth is in the same frequency space, roughly.
Yeah, Bluetooth, all of them are on the same frequency, and they all collide with each other and raise havoc. And Carl and I lost $2,500 because of that.
Oh, no.
Oh, that's your excuse.
At a contest in Vegas. Well, it sounded like we were on path to get one of the lead roles, and then the Wi-Fi cratered. I mean, that same band, there's other things that use it, like microwave ovens. So to this day, if we try and use our Bluetooth headsets and we walk too close to when we're making popcorn, the audio drops out. Which is not a very positive thing, I think, to say about the leakage at the microwave oven, but...
Yeah. Maybe you should stay away from that microwave when you're using it.
Well, I think I'm just going to have to be more careful that the robot has enough autonomous behaviors that it doesn't depend on me driving it.
I guess the other thing you could consider would be something like LoRa.
The fallback that we didn't get implemented was to make it autonomous. If we'd done that, we probably would have done a lot better.
I'm still hoping for some voice control, but I haven't gotten into that programming space yet. But it looks good on the internet. Of course, it always does. We'll see.
Voice control is pretty iffy at big events, too.
Yeah, you got lots of background noise.
Consider remote control IR type.
Yeah, all kinds of possibilities. One thing that I'm sorry to keep taking up the bandwidth, but the other thing I'm concerned about is the thing has gotten heavier and heavier. It's up to 15 pounds now. And I'm still planning on carrying that on my back for hours. So we'll see how that works out. I may want it to run along beside me more than I thought.
Were those legs made out of PVC tubes?
Yeah. It's PVC tube with the motor stuck up inside of it and screwed in.
You got some sort of steampunk decoration to go over those?
No, I do have some copper film that Carl was telling me about, and I've gotten some, and I'm going to put over them and make them look like they're copper pipes when it's said and done.
Oh, good deal.
Cool.
Nice electrically conductive copper. That's what you
want. Maybe brass. I think I have both colors.
You want your robot to ground well.
Have you thought about like a trap door? Because like what do dogs do eventually? They'll on the carpet. So.
Well, that's not a behavior I've been planning on implementing.
Hey, but look, it left a Ryobi.
That's right.
I actually had to take one of the Myobis out. I was going to have two of them in there, and it just adds more weight that it doesn't need. And so I've got the two slots in there, and I can stick one in or a second one in when I want to switch batteries, just so it keeps the power up during the switch. But I'm not going to keep both of them in at the same time anymore.
You could do the bad dog routine, and as part of your show, bad dog.
I'd be happy if I can implement follow me. I think go straight, go back, go will be easy, but follow, that depends on some sensors. And I could say, follow the closest person, but then in a crowd, somebody can walk closer and all of a sudden he's following them.
Walks right off.
Robodog, stop.
Yeah. Okay. I think next in queue we had Dave, but he stepped away from the camera for a minute. Then we had Ed. Then we had, is it Navin or?
Oh, you can call me Naveen.
Naveen.
Yeah.
Okay, cool. So we have Dave, Ed, and Naveen. And Dave, I saw you put some stuff in the chat on the I2C MicroPython slave. Did you want to walk us through that or say anything or just drop it in the Slack? And you're muted.
I just wanted to drop those in and let people know that there are those two. The one that is on GitHub is from Morano. That's one from a couple years ago, and I also looked around on the web and found the other one that I put there. And I can't vouch for either one, but somebody was looking for slave I2C for MicroPython, and those both claim to do the job. The other thing I wanted to mention is that starting next Tuesday, I won't be available for the next several weeks because on Tuesday I got my other knee done.
Oh my. Busy summer.
Oh yes.
That was the first one going.
Going great. My only negative on it is that one's supposed to be able to get one's leg completely straight. Well, mine's still at 10 degrees, and it'll probably always be 10 degrees, but hey, it works.
Now, as I recall, you prepared for that one with a certain river cruise. Are you going to prepare for this one with another river cruise?
Well, actually, I'm going to take a river cruise afterwards. In March, I'm going to do Mississippi from New Orleans to Memphis.
Fantastic. Well, we wish you well. Thanks for those links on the MicroPython. They're put in the chat, so whoever needs them can find them. I know I put in my reference list because it could be handy. Okay, next, Ed. So returning DPRG member, Ed, and then Naveen. So Ed, what have you got with this visiting? You taking care of your dad?
Oh, we're taking care of my mom. So, she was doing pretty well, but she went into the hospital right when the night I came in. So it ended up being really good, I guess, that fortuitous that I happened to be here when she needed somebody around. So that's what I've been up to. I moved to Seattle about 10 years ago. So I've been up in Seattle and never really got super involved with the Seattle Robotics Society up there. But I've recently been doing some more electronics and 3D printing type stuff. And so I have some show and tell I can show you there. Let's see, hopefully I can share my screen. Let's see here, where is, I don't use Google Meet a whole bunch. Okay, present now, a window. And let's do photos. Wow. All right, can y'all see the photo gallery type looking thing there?
Mm-hmm.
Yeah.
All right, so I've been working on a pin plotter. So this is all 3D printed These are eBay motors I got for $3. The NEMA 17s. It's a T-Bot design. And go to the next one. You can see in this video how it works for the motion. So pretty easy. You can see that square underneath it. That is the approximate drawing size. And then right now I currently have this, it's a single belt design. So the belt is kind of serpentines all over the place, and I'm using 3D printed pulleys. And, it's all sort of prototype, so there's definitely some changes, but you can see here in this video that it's a differential drive style with the single belt. So if the two pulleys go in the same direction, you get motion in the y-axis. And if they go in the opposite direction, they go in the y-axis. And if you go in the same direction, you get motion in the x-axis. And then right there down in that little carriage on the y-axis, you would have the pin lift mechanism, which hasn't been designed yet. But you can see me just futzing around with it there. It's a little stiff. Definitely a lot of questions about it, but it's not as particular as a 3D printer situation because there's almost no weight, right? So it's very lightweight. So it doesn't need to be quite as robust as like a 3D printer or as a milling machine or something like that. And then the other thing I can show you is this is a boring demo because it's just the stock demo out of this e-paper display. This is just the demo that they ship. But I have there it is. I'm just showing. This is in, I think, Arduino, maybe MicroPython. But I have that same thing implemented using a I2C expander, which does some of that in there. So I can drop that link to that code base into the chat if you're interested in doing some MicroPython. Wait, hold on. Sorry, this is the Arduino version. So this, you can do some Arduino if you want to drive so it's all C, C++. If you want to drive a, I don't know why I call it QtPy, so I must have messed up the name of that repo. So sorry about that. Oh no, because it's on a QtPy. So it's on a QtPy, but it's using Arduino. So if you want to drive one of those, they take about 6 I/O lines. If you're using something like one of those little ESP32 jobs that are just real simple, one of these little things, your super minimal number of I/O that you have, you can use that I/O expander to get it done. And what the library does is it uses 2 of them for SPI and the other for data and just bangs it out. And anyways, kind of makes some clever use of the different pins. And I just realized I was probably showing you a picture you can see. All right, so then on to the next thing. My friend gave me a bunch of these string LEDs. And you can see my really messy workbench there too. And I did the classic, stick them in a grid on a piece of cardboard. Did the grid display. Pretty high resolution display, a pretty fast frame rate using the Adafruit libraries. And that is also with Arduino, not with MicroPython. I've been doing some MicroPython. I'm doing a lot of MicroPython and a little bit of CircuitPython. So if you dig around in my GitHub, you'll see that there's some like that. And then I will drop a link to that first project with the pin plotter, which I meant to do as well. The pin plotter right now is just OpenSCAD files. So if you're into parametric modeling with OpenSCAD, that's what I use. And I've got some other fun stuff on my GitHub if you're ever interested. And that's what I've been up to. Not a whole lot of robotics per se lately, but a lot of things I learned when I was doing a bunch of robotics. So there you go.
That's pretty cool.
Yeah, just for the heck of it, Matt, see if I can get it up there. At the top there is a RP 2040, which is the standard Pico, but in a small form factor that runs the MicroPython. And then down below happens to be a 12-cent Arduino, Super Arduino, if you will, ARM processor. They're 12 cents for the 22-pin or the 8-pin or the 16-pin version. Anyhow, for what it's worth.
What's that? What's the part number on that second board?
Okay, I'll put that up there for you.
Thank you.
It turns out that if you buy in the 5,000 quantity, the 8-pin version, they're 8 cents a piece.
Score.
But the one I have is the 22-pin, which is the 0.625 millimeter spacing, which is a bitch to solder. But they have also a 16-pin and the 8-pin version, which are at the 1.25 millimeter. That is essentially 50 mils spacing, which are much easier to solder. And they're all about 12 cents a piece in the 50 quantity.
How do you program those? Does it have like a USB connection on it or something? Or
no, they're the usual ARM boot programming, or they have the 2-pin serial, just like the SP micros. So I haven't gotten to the point of actually programming it yet. I'm working up to that. They do have a set of programs, the libraries that presumably work with Kyle. I'm working towards that, but with my leg and what have you, I haven't quite got there yet, and it'll be a month or so. I'll report on what the progress is.
Okay, thanks.
David, can you check the link on that? I'm having trouble finding the actual part that refers to PY32F00A. I see images. Huh. It's a F02. Okay. Oh, maybe that's why. All right. Well, while we search around with that. So, thanks, David. So, I think next we had questions. We had Naveen, and then we had Pat, then we had open mic. So, Naveen, feel free. Maybe you can maybe see how the rhythm we tend to have is, or make your own up. It all goes.
Hey, thanks for this. So I'm just starting on the robotics, not nowhere close to what everyone is doing here. It's like, I mean, honestly, my second week. What I'm trying to build is like a very simple toy for like dog kind of robot. I know that like that statement itself means many different things, but just bear with me. I will keep showing you the progress as we keep connecting every Tuesday. My first question to the group is like, what do you in general suggest? Where do I start with robotics? I have good experience with the programming side. but I never honestly touched the hardware in my entire life. Right. So this is, I'm looking for actually a mentor kind of thing, someone who can guide me in this journey. That would be great. Any books I can start with? My first question actually is like, where I'm right now is like I built a 3D model. I'm trying to build a simulation on the 3D model, to take care of the center of gravity issues and all of that. Is that the right way to start it? I can show you the 3D model and where I am at in a couple of seconds. Okay, let me go ahead and actually pull that.
No, I'd get a kit like Atlas from Boston Robotics, something like that. Something simple.
No.
To start it with.
Nowhere close to that. Yeah. Yeah. Just give me a second.
So you're talking about quadrupeds?
Yes.
Four-legged robots?
Yeah. Oh, I can't share because Chrome doesn't have. Oh, okay. That's okay. Yeah, I will hold you back. But yeah, my question is like, does everyone actually, when I saw what Doug was building for that dog, that's my first question actually. Do you worry too much about how the robot stays stable when in the real world? Like, do you worry too much about the center of gravity issues, or am I overthinking? Should I spend so much time on getting the right design in place, right distribution of mass of different components and all before I do anything? I see Ed waving his, nodding his head. So does that mean no? Yeah.
If you're just starting,
Yeah.
The way they kind of tell you is 2 legs are unstable, 3 legs can be stable, 4 legs will always be stable, and any more than 4 legs will always be stable. But I have a suggestion. Since you've never handled hardware,
Yeah.
do you have a 3D printer?
No, I don't have a 3D printer.
Right.
Yeah.
Okay.
But I have one in the Richardson library. That's where I'm planning to get it. I know it all sounds, I'm betting too much on the software, but yeah.
All right. No, the reason why I'm saying is because there is a very nice hexapod robot, but that's 3D printed. It prints very well. It was designed excellently. It's used in schools a lot, and it's would teach you about servos, potentially a sonar sensor. It would teach you kind of like how the program would be written to make one that had multiple legs. It's called Vorpal, I believe. I'll hold on a second and I'll show you one.
Please. Yeah, that would help. Yeah, maybe I shouldn't have started with quadruped, right?
I'd start with a 2-wheel robot.
Okay.
Yeah, something simple, 2 wheels and a caster, something like that.
Differential drive.
Okay.
Yeah, different drive.
The differential drive is a much easier starting place, and I think that's where most people do start.
Yeah, but here, this one, if you want something that
just go straight for the balance spot and the thing and that kind of deal. Just go straight for it.
Yeah. Okay, so if you pin me, you can shoot.
Yeah. Send them down the rat hole.
Okay, but
actually, a blimp will not have any balance problems.
Yeah, and then there's
start with a blimp.
There is another type.
You talking about me, Karim?
Very basic robot that you have 4 wheels, 4 legs, and they touch 3 down at every time. So there's 3 sets of. It's a very primitive robot, but again, it's something you might be able to learn from, and I can show you one of those here too. But this one is available in kit form if you don't have a 3D printer. It has 6 legs. You can either get it in a kit, you can get the printed kit and buy the rest of your parts. It works off an Arduino Nano, and I think it has a Bluetooth module in it too.
What do I search for it, Doug? If I were to get that, what am I searching for? What is the name of the product?
I want to say it's VORPAL. I'll try to look it up.
Like the Vorpal sword?
I don't know.
I'll figure it out. Yeah,
but it's a very easy. I mean, if you buy the kit, you don't have to do any of the 3D printing. And like I say, if you're doing the 3D printing, the model prints very well. Okay. Oh, somebody's found it for you. Carl's found it.
Also, you might want to look at those parts too while you're doing this, because I know if you're going to a library and that kind of stuff, they're going to want to limit your time, and they're going to want you to be there the entire time of the thing. If you owned a 3D printer like a lot of us do, we set it up, kick it off, and come back when it's done. You're probably going to have to schedule your parts for printing, and in some kind of way where you print 2 or 3 of them at a time. I'm looking at, I've seen that model, and I think there might be 1 or 2 of those parts that may take an extreme amount of time that may be problematic. I'm going to guess, though, that somebody on this channel, I'll even be one to volunteer. If you can't get it printed, get a hold of me. I'm about to kick off a 2-day print right now. But besides that, we can probably work something out. It's not a problem.
Yeah. And that's true. We could all print you some. Maybe if we could get enough people with 3D printers, we can print you a couple of parts each. But it comes in about 5 different sizes. I think the biggest one is like this. Okay, so this one is like their original size model that they made. But if you do this one, you'll have learned a lot.
Got it.
Yeah.
But Doug, are you really suggesting a multi-leg robot as a?
Well, he said he wanted to do a leg robot. If you just want to learn about robotics, then I would not go with a leg robot. Okay. But if that's what you want to do, if you want to do a leg robot, this would be, since somebody else has gone through all of the design work for you, you can concentrate on, well, how do you put my programming into a microprocessor? How do things like servos work? How do I handle the wiring? You can learn a lot of things from this model.
And just pulling tools together, tools and parts, that can take a while to get started. Just
if somebody just said, I want to build a robot and it's the first robot, I would use the one that we used in our the little cheapy $23 robot from Amazon that we used for our training class. That one is very satisfying because you'll have a robot running around on the floor, and you'll learn some of those things. But if you want a leg robot, I still think this is a good choice.
Thank you.
Like I said, there's another style that has 3 sets of legs where.
It's 2 tripods.
Two tripods, right? And they keep going back and forth. But I don't know and I have one of those, but I don't know where you get a kit for one of those.
Okay.
So that's
You need to really ask yourself whether you're wanting to learn robots or whether you're wanting to do leg robots. Leg robots are much more complicated, and as people have said, the 2-wheel differential robots is really a good place to start. And as Doug said, they've got a kit out there that's $22, $25. Get you started.
Got it. Hey, thanks everyone for your suggestions on the links in the chat. I noted them down. I'll definitely explore all of them.
And if money is no object, you can buy a Boston Dynamics Spot for like $80,000. Okay.
I thought they were down to like 24, something like that. 24.
Is it that low? Boy, I'd be surprised.
I think it's pretty low. That's without accessories.
Oh.
I put a link in there for one for $1,600.
Yeah, it's $1,600.
That's
Cheap.
the
Knockoff,
Some
knockoff cheetah.
knockoffs. Yeah.
There's a base price, and if you look on AliExpress, because I got it in my wish list. It shows up every time I go in there. There's a 4-legged kind of robot that works off servos for about $650 as a kit. Now, how capable it is, don't know, but in fact, it looks cool moving around, and I've considered it. I just hadn't had a spare $650 to throw at that because I'm buying laser cutters and other things and other robots that fall on their face. But that's another story. I'll be quiet.
I do have something that I wanted to. Are we in general talk now?
I think Pat had a question after Naveen, and then open mic.
Okay, I got something for open mind and something to aim at Pat. That's because of something we talked last week. Go ahead.
Okay.
Naveen, are you done?
Yeah, I'm done. Thank you.
All right.
Sure. Feel free to come back with questions in progress. I mean, we often show like really small steps each week, or sometimes steps backwards, but
Yeah, we do. Thanks.
yeah, no problem. So Pat.
So I had a question. I had it written down for last week, and I just didn't get around to asking. So this week, back to my famous motor control. Always looking to improve my motor controller. And it's pulse width modulation frequencies for a DC brushed motor. So does anyone have an idea on what frequency works best with some of the smaller DC motors? I know that the standard frequency, like an Arduino standard frequency for pins D9 and D10 that I use is 490 hertz.
Well, it's basically whatever your H bridge will tolerate. You use as high a frequency as it will tolerate.
Yeah, because it dissipates more power.
Yeah.
Yeah, the higher you switch it, the more power you're going to end up using, because you get switching loss at that point.
Right.
But, and usually you got to get above, about 10K so that you can't hear it. So it's out of the audible range.
Okay.
I usually, and depending on the microcontroller you're using, there may be a limit to what it'll run as well, as far as the registers and how you pre-scale it. I stick around 19K, seems to work pretty good for me. And that's a pretty standard pre-scaler setting in the PWM on the chip I typically use. So that's typically where I set them at. I mean, you can get a lot faster, and I agree with Ray that it's your H bridge, not necessarily the and you really should go as fast as H bridge can go, because a lot of the older ones, like the little what were the 298s, the little 14-pin chips, they had like a 9K limit or something, I think it was.
Yeah.
You could run them a lot faster, but they would heat up quite a bit.
The other thing you run into, Pat, is like if you're using an Arduino, there's only, because of the pre-scalers available, I think there's only five selections. And I don't none of them are up in the 19K area. I want to say if you get to 4K, I think that's the maximum they have. But if you put in how to change PWM frequency on Arduino, and there is a famous link that will tell you exactly how to do that and which ones are, you got it right there. And you can see which ones are available. And you can see, so that one you're looking at, well, I guess that one might actually go up to 31K and 62. I didn't think they went up that high.
Yeah, this is talking about using it on an Arduino Uno or Nano.
Yep, that's the one I was talking about, that link. And you can drop that in there, and then go ahead and try each one of those in your, each frequency, and you can do a little experimenting and see which works best for your H-bridge and the Uno or whatever you're using. This applies to the Mega too if you're using a Mega chip. Okay. So
the other question I had: has anyone used the 10-bit? Is that available on the Uno? I've never heard of it. I thought it was an 8-bit for timer 1, but they're telling me there's a 10-bit.
Well, okay. Here's another one that you can get around this, but you need to think about it. I believe you're going to end up using, if I remember right, you end up using 2 timers to do 2 motors. Okay. And I'm trying to think of why that would be, because you should only need 1 PWM pin.
Yeah, they're telling me there's 2 timer compares in there. So there's timer compare R1A and timer compare R1B.
Well, a lot of times they'll have like the complementary. So because you have 2 sides of the H-bridge, right? You're driving, the high FET and the low FET. A lot of H-bridges that are sold for robots, you just have a single PWM input, and then you give it a direction, right? So it directs which side of the H-bridge that you really want to run.
Right.
And that's what those are, isn't it? I mean, because normally a timer will have multiple compare registers, which is really all PWM is.
Yeah.
Right? You have a timer, and when it reaches a certain number, it's going to drive an interrupt or drive a pin. And usually you can have multiple matches, right, and driving different pins.
Okay.
Yep.
Now, in that light, if you look on the website under, I think it's tutorials, I wrote an article a while back about the 3 modes of how to use an Arduino with that particular 298, and my mind's kind of blanking right now, but you can in that particular article you can see the code and whatnot that you can use. I'm going to put in DPRG.org. So we get that.
Just be sure to choose a frequency that your wife can hear, but you can't.
That's why I use 19K. Believe it or not, my wife can hear that.
Wow.
I'm convinced the reason my dog attacks my robots is that I'm down into the frequency he can hear.
Whatever frequency I speak at, my wife doesn't hear.
She accuses me of that problem.
I see Mickey Dean has raised his hand. He needs to just pipe up.
Yeah, Mickey, you're on mute, so we can't hear you, but feel free to unmute yourself. Let's see your hand wave again. And there's a chat, so you can talk or you can hit the chat window, put a text. There you go.
All right. I'm sorry. Pat was bringing up the motor controller, and I'm using ESCs to control each motor. And I'm wondering if I should just bite the bullet and buy a motor controller, or can I get a robot with just these ESCs? I mean,
ESC is a kind of motor controller.
This is where I don't fully understand the nomenclature and all that, and didn't know if I needed something extra because the H bridge and all this, and I'm guessing that's what the ESC is kind of doing with the fact that it can go forward and reverse. Right. Is that correct? Okay, just wanted to make sure that all right.
So my opinion on it, it's just my opinion. An ESC will give you a speed going forward or reverse, but I don't believe you can close the loop. So if you tell it to run at 1 foot per second, there's no way to ensure that when you power it on that it's going to be at 1 foot per second. If it's going over a bump, it's going to slow down or speed up. And with a motor controller, you can have it try to maintain that 1 foot per second, even if it's going uphill.
Yeah, but if you don't have encoders on your motors or some way to tell wheel speed and that kind of stuff, none of that's really going to matter. I mean, That's right, though.
But like an ESC typically doesn't have a closed loop feedback into it.
Yeah, there's no way to. Yeah,
You could wrap one around it if you had encoders. You could wrap one around, but then you'd introduce lag because the encoders would be pretty far, and the PID loop would be far removed from the ESC.
Yeah.
Okay.
One of the things I did, for example, on an RC car, was I put a encoder in the on the drive shaft. Okay, so that means the motor went through it's what do they call it? The small gear, which drove a big gear, which drove the motor shaft, which went into the differential, which turned the wheels. And so I was getting feedback on the speed from that encoder that was on the motor shaft, and that was close to loop. And so using an ESC can be done because all you do is modulate the servo signal that you're sending. Yeah, your PWM that you're sending. So that's very doable. In fact, Traxxas sells an upgrade on their RC cars where you can get that built. You just add it on to the thing.
The encoder? You got the encoder on there? That's nice to know.
Yeah.
I actually do not. I have. Traxxas kind of has a bad reputation as far as I'm concerned right now because of some of the things they've done, but that just might make me reconsider that.
Yeah. Now, I don't know if it's on all their models or specific models. I've just, seen it, people talking about it.
Okay. Thank you.
Yeah.
Appreciate that. Good information.
All right. Pat, Carl, can I talk now?
Oh, I think so.
Okay. Pat, we were talking the other day about Compass 5883s. And everybody was kind of saying, I think Ray was struggled with them. And I think Kareem said that, he had some issues with them too. And so anyway, I found a series of articles, because remember I was talking about this very specific GPS with 5883 compass on it.
Yep.
And I told you I would try to get it done. Well, things stepped in life, so I wasn't able to do it this week. But I'm going to put in 4 links on this guy's video series, and he pretty much, you will know. Let me put it this way: I don't know if you'll get your 5883 to work perfectly, but you will know a lot more about how it works than you do now. Okay, so I'm going to go put those in the link, and we'll go with that. That's all I wanted to say, because I am going to be working with a 5883 to see if I can get it to work.
Well, I'm going to do the same thing because I'm trying to get the outdoor bot to know its position when it's standing still.
Okay.
Maybe it's possible to correct it when it's moving, because you can get a heading out of the GPS when it is moving.
Well, I will say he got his to do pretty good. He said it was absolutely key that you calibrated it. If it's not calibrated,
I've been reading that as well on a couple different ones. That some of them said you didn't have to do anything, but some of them were showing what happens when you map the 0 to 360.
Yeah.
And when it's uncalibrated, and they were plotting it, and it's definitely out of whack.
I don't remember. Do you know what the letters in front of it are? I know it's 5883, but what is
HMC 5883? I believe.
HMC?
Yeah, 5883 or QMC 5883.
I know what that means, by the way. HMC means it was made by Honeywell.
Yes, I know that.
The Q is made by some company in China.
Yeah, and the two are not exactly interchangeable.
Yeah. Okay. I don't know which one he thought, but okay, I'm going to put those links in here.
So while he's putting those links in, I don't know if y'all can hear me if I'm not using my normal headphone mic thing.
You got it working.
But I wanted to throw out some info that might be of interest to especially Ray and that. And last Saturday, there was a North Texas Machinist Club here at the Makerspace. And the reason why they were here was because our normal place they meet was being revamped. But so for those who are interested in machines, like the lady that one person got the other week and show us, they meet on the fourth Saturday of the month at the Gilbert Reeves Career and Technical Center in Garland. And their website, in fact, the guy made a comment that he would like to somebody help him with building a better website. So if you want to do that, also, so contact basically is the www.ntmac.net. So FYI for people.
I think Michael's just hit an asteroid field.
Yes. I'll put the website in the chat area, but and they're simply going to have a little contest. Well, help the kids in that school with a contest to build a oscillating engine. So if you're interested in that, as I said, it sounds like a nice group. They don't charge. Overall, I was impressed with them.
Okay.
So
thanks, John.
So I'll put that in. That's why I said, because, well, I know in our group we have a couple people that have machinist tools. So I thought it was a good, reference source type thing. So that's all I have, unfortunately, but I thought it was interesting.
Well, John, there's a guy at the Makerspace. I was busy. I mean, I'm sorry, I wasn't listening real good. There's a guy at the Makerspace who's wanting to build a website.
No. It's this group. They have a website, but they're a small group, and he doesn't know much about HTML and all that stuff. So, hey, if y'all want to help out on that too, hey, we would appreciate that too. In addition,
it's a machinist group. What you're saying, though?
Yeah, they're a machinist group, and it looked like interesting. I'll type some of this stuff in chat. So if y'all wanted to look at it more closely there.
Cool.
I don't know how well this mic is doing. It's not my normal procedure.
Yeah, you sound fine.
Good.
Yeah, Doug, the part that I was looking at was actually the 5983. It's the SparkFun part. I don't know if you can see that.
Not yet.
Oh, not yet? Really?
There it is. It popped up.
Oh, okay. Anyway, I don't know if that's related to the 5883 or not. But that was the one that I used, and it was on sale at SparkFun, and I thought, oh, what the heck, I'll buy it and try it. It was extremely sensitive to, anything metallic that was within a foot of it.
Wow.
Yeah. So
let me ask you a question, Ray. I didn't mean to interrupt you, but would that be, you said just a foot, so it would be good on the fixed can. I mean, as far as maybe using it as to help you find out, the goal, which goal you're at or whatever. It wouldn't be.
Or, a heading. Yeah.
Heading. Would it work?
I don't think so. I think the B&O is pretty sensitive to rebar in the floor, and that thing I think was it'd make a great metal detector. I think
Yeah, maybe you could detect the screws in the arena there.
Yeah, any it seemed like any kind of metal.
I'm not sure how that would help, but you could navigate based on where the metal is in the arena.
Use it as like a beacon. The screws and the
yeah.
Just pointing at the cans, and the can that has the strongest field or the strongest signal, you just go to it just for them.
Yeah, just
your can.
Cans are aluminum, not metal.
They're not going to be.
Oh, you have to get an aluminum one then.
A proper tin can.
Yep.
I'm sorry, man.
Then we have to remember to bring our steel-toed shoes.
I've been out in space.
Ooh, yeah, there you go. Magnetized steel-toed shoes.
So, who's going to pay me to wear steel-toed shoes along with my orange vest? My orange shirt.
I get you a bag of popcorn.
Yeah. The roboticist nightmare.
Just to make Ray's day.
Carl, I have something ready now. So
yeah, we're an open mic night, so feel free. Anybody, just jump right in. We're good.
Okay, so I've got an update for my claw, for my robot arm claw, and I already know. I'm just testing. This is a test deal, prototype. Testing the motor. I can already tell that the motor on the arm is definitely not going to work. I'm using these little yellow motors right now. Let me demonstrate. Let me see if I can present without any problems here.
Looks like it's about ready to play the guitar there.
Yeah. I'm going to teach it to do the guitar.
That'd be cool.
Let's see. It's not going to allow.
Might be a dangerous place to have that thing. If it goes haywire, it's going to hit one of those nice guitars on the wall or something.
Look, just pin me to so you can see it enlarged. Yeah, I'm going to have it swing around and play a guitar. So anyway, I'm using these gears. I got gears on here for two reasons. One is just for the challenge of it. So what I'm going to do is there's a claw. Y'all see the claw?
Yep.
It's got to hang on like you would a regular claw machine, and then when they push a button, it'll drop and pick up the item. So it's going to go on the end of that arm, which this motor won't handle this arm, this claw. So anyway, I got going out. I got going in. And there'll be gears on here just for show, just idler, just for the kids to like. And here, I don't know if y'all can see this very well, but let me try. Okay, and it goes this way, of course. Let me go out a little bit. Oh, it gets hard. Oh, is that a point or what? Okay. Gonna swing around like this, and the kids can go in and out like that. Sit. Okay, so there we go. Now let me try to explain this to you. If you can see it, can you see this brown gear right here, or is it real? Yep. Is it real grainy?
It's pretty grainy.
Okay, well, this brown the brown gear is stationary and bolted to the pedestal here, but it meshes with these gears, right? With these purple gears. So the motor is attached to the gear on this arm, but when I move the arm, these gears turn. When I move this arm up and down, these gears are meshed into this stable gear, and it turns those idler gears until you come out here to this elbow, this joint here, and it turns that gear. So I got one motor controlling all of that. So I'm going to have to change motors, but I'm on my way. I'm on my way. Down here, I'm just using the little cheap yellow motors. I think the cheap yellow one down here on the base is going to work just fine, because I'm not drawing hardly any current there. On the arm, I'm probably going to switch to this guy right here. He's a pretty big low gear, really
Hey, Mike, can you show? Can you show where that's going to go? Where is it going to go?
It's
Yeah.
going to go. Let me pull this closer. Maybe you can get there. Okay, can you see the gear now? Okay, wait a minute.
Yep.
Can you see the gear?
So you're going to replace that one?
Yeah. See how I'm activating that?
Oh, cool. That's boy, that's going to be a lot of motor. That's cool. So the one in front is just for show.
No, the one in front is actually meshed to those blue ones. Watch.
Yeah, I see it. Okay.
So it stays stationary, and because it stays stationary, it forces those idlers to turn and go up here to this, what I call the elbow, this joint, and it forces it to turn this gear on the extending arm, the second arm.
Well, they're doing a really good job of keeping it level like you wanted to do.
Yes. And like I told y'all before, I'm doing a lot of this just for eye candy too for the kids. So they'll see those gears going. Of course, these gears, these idlers, I'm gonna make them different sizes and put spokes in them so that I probably have LEDs shining out or something. So, but I really like this guy here too. This see that turning? Can y'all see that? Okay.
Yep.
So anyway, that's what I got going. But this big motor here, this guy, where am I at here? It's hard to see. This guy, like I said, is going to go right there. Right there. I'm going to have to mount it. So, because that little yellow motor ain't cutting it.
Okay.
But I hadn't tested it. Go ahead.
Okay. I was just wondering if you could get a motor with a 90-degree shaft that might make it easier.
I bet I could, but the deal is, I know I could. Because they got these, you've seen them with the what they call the worm gear. It's got that square end on it.
Yeah.
But this I had laying around, so
okay.
I don't have a problem buying it. It might be a better design to do that. But,
Or you could 3D print the elbow gears.
Yeah.
I guess I could. I guess I could. I've gotten this far with gears, so I can continue on, huh?
Yeah.
So anyway, there I'm at, and I think I just at least deserve at least a black star.
Okay, black star, you got it.
Yeah, possibly silver. That was cool.
All right, thank you. But I'm making progress. So, and I'm getting the kinks worked out. So that's good. Anyway, I'm kind of done with that. So what I was talking, with my new machinist stuff I got out in the space shuttle, I can make some bushings and stuff that'll and some pins. I plan on making some pins, some drive pins for those gears to ride on. Right now they're just riding on little plastic. Are you
still loving them?
Huh?
Are you still loving those new tools?
Oh man, I ain't had a chance to play with them since that night. I've been doing other stuff. But heck yeah, man. That's
out there and look at them every day.
I'm just gonna stare at them.
Yeah,
so.
That's really cool, Mike. I mean, be able to go get two machines like that real quick.
Yeah. Well, see, I'm retired, but I'm working. They asked me at my old job. They're real desperate. Is what it boils down to. But they asked me to come in and work part time. So I'm working like 24 hours a week at my old job, just in the machine shop itself. So I'm making enough money to burn,
Yeah.
Just to buy junk with, and I'm okay with that. So I'm still retired and everything, but I still make some money to buy some toys. So that's how I was able to afford that stuff. Anyway, I'm done.
Cool. I don't know, Mike. I might want to get adopted if you got all the money laying around,
Maybe we can get us a race car together, over here.
Oh yeah, there you go.
Start building on it.
Harold, you know the Mega Millions lottery.
Oh, I
Drawings
know.
tonight.
I firmly believe that if you don't play, you're not going to win, and
That's
so I'm not holding out high hopes, but because I'm playing and other people aren't, I've got infinite amount of chances more to win than they do. So,
oh, you did, huh?
you know, so yeah, because if they're not playing, I guarantee they're not going to win. If I am playing, whatever small pittance of a drop in the ocean that I might have a chance of is way more than they do. So
yeah, 1 times 10 to the minus 9th, I think, are the odds.
Something like that, yes. But still, that 0 over that is still way more, way less chance than that. So, I mean.
Oh, yeah, yeah. Yeah, I think it's, Dumb and Dumber. So you're saying I still have a chance?
Yeah, exactly. I usually play those things, yeah. Are they stupid? My friend tells me, he goes, well, if you're doing it for the enjoyment and fun on it, why don't you just take that, $6 and go buy several loaves of bread and go down and feed the ducks? And I go, they're not on that at all, but I don't know, the ducks, I have a better chance of getting bit by a duck if I do that. So I think we're just going to leave that alone.
Yeah.
Yeah. But if I do win the lotto, there may be a little bit, but there'll be no doubt that I won the lotto. I might have one of those spots just for the fun of it at that point. I mean, that $850 million. So if you do the math on that, you're going to get about $550, $560, and 30% of that goes to the government. I think that's still a lot of money left.
Oh, yeah, money.
That's a lot of 8-cent ARM processors.
Yeah, it is.
That's right. You could probably buy enough to get that price down to that, 8 cents.
Think about getting your own fab.
Yes.
All right. Well, that moves us squarely into the open mic night. So it's a free for all, guys.
I'm about to be not happy.
Uh-oh.
Well, no, there's this really cool thing I wanted to print. I'm bought some special filament just to print it, and now I'm looking at this thing. It's supposed to be a Swirsky triangle. If you take a triangle, equilateral triangle, and then you draw another triangle between the bisect each one of the external lines, and then draw a triangle in that, and then each one of those you bisect that and do a triangle that. There's a 2D volume of it. It's a fractal. Goes on forever. Ends up having 0 space in it if you make a 3D version of it. Somebody did a real cool version of that, and I ain't printed one in a long time. And I want to print up, and I'm putting it in spiralized mode. So they say you can print it in spiralized mode. And I'm looking at my spiralized that I'm doing Cura, and I have lines of that thing jumping all over the place, and that's not going to play well for this model at all. So, rats. That's all I got to say about that. Rats.
Man, it's always something.
First world problems, right? First world problems. Why has it always got something to whine about? What does that mean? Is it me? Am I the common denominator in that?
Is any of y'all thinking about the fall competition this year or not? Or have y'all talked about it? You outdoor guys?
Who's building?
Huh?
Who is building? Yeah.
I hope to have something to run, but like I said, I'm having some life problems that it might step in the way. But we'll see how it goes. I've got a set of those carriages that you haul babies around in. They have real light plastic wheels that are about 9 inches big, and they're real light because they're meant to be pushed around. There's not a whole lot of traction on them, but they're really light and they're fairly good size. And I'm thinking of trying to build a very light robot. Have a strategy of especially since the last one I built. I don't know if I told you guys that I did some testing after the contest, and I found out that somewhere around 10 minutes, the motors were hotter than a cheap pistol. So I was concerned that that would not have been a viable design, even if it had been successful. So I'm going to see if I can. I'm definitely going to make a differential robot. Just so many problems are spiced up. Then the second thing I'm going to do is, I have considered mower wheels, especially the ones that have like the built-in gears on them. You know, I've seen those. But right now, these I have them, and like I say, I'm still in the how do these all fit together mode. You know, I'm trying to figure it out. I did get I just happened into a piece of carbon fiber, and I didn't make carbon fiber. I didn't mold it or anything. It was a piece of just a piece of flat carbon fiber. So it's a piece of flat carbon fiber about this big, and it weighs 30 grams. I mean, it's incredibly light. So I was thinking that might be fun to make a base out of, so that if I can get the other parts to work, and I wouldn't have to have as big of motors if it's a super light. And a lot of the problems are smaller if it's super light. So anyway, that's what I'm thinking now. And those big wheels will keep it up. Like Ray last year, you were always kind of dragging butt, and you were doing good. There's nothing wrong with what you were doing, but you were dragging butt all the way, and it got till you hit the horse apples. You might have gotten to that second cone. So if with a 9-inch wheel, you just run over all of those things. They don't come in. So anyway, that's what I'm looking at right now. I'm interested. Ted dropped off, so I don't think he could update us on his. I'd really like to know if he's made any more progress, because it looked like he had a pretty good base going there.
I'm working on possibly a 10-inch wheel.
10-inch wheel.
10-inch knobby tires.
Okay.
So to be able to do everything, and of course it'll be made out of wood and have a big battery in it and whatever else I typically do.
Yeah.
How wide are your 10-inch wheels? Are they like an inch? Or are they like 4-inch? Or
4 inches wide. They're snowblower tires.
Cool. Serious?
10-inch pneumatic wheel.
Yeah, the ones I was talking about are very narrow, because they literally come off of a baby carriage.
I also thought of using like a 13-inch bicycle tire. Same thing with a plastic 3-spoke rim.
I've seen those. Like you said, the small bicycles. You can go to down here if you go to Goodwill. You can usually pick up one of those bicycles for like $10. So $40 to get 4 wheels wouldn't be a big deal. You might be able to
pink streamers that you can put on your robot too.
Yeah.
Oh, and you got to have a bell. You got to have the ding ding.
Yeah.
Have that.
Yeah.
Kind of reminds me of the pram bots that they, toyed with people in New York City. They had a remote controlled pram, I guess, and it had it looked like a kid in it. And the thing they would just reel it up to a street corner and make it look like it was just rolling into traffic, and trying to figure out what the people would do with it, and it would make little baby crying noises, and a lot of people just let the thing go. I don't know if that's New York City or what.
People to their death in a traffic accident.
Say that again?
They were trying to bait people to run into the street with cars.
That's right, and grab this runaway
Save
pram.
the baby.
Yeah, that's right.
A lot of people don't have great reflexes to decide what to do when there's pressure of the moment.
Yeah, that's true.
Yeah. Yeah. But, so there you could call it Prambot.
Okay, so if we're going to talk about prams, there's a link to a jet-powered pram.
Oh God.
P-RAM.
Complete with crying baby in it, right?
Oldie but a goodie.
Yeah, I think they were supposed to be 10-inch wheels. I think they're more like 9 3/4, but they're 2 1/4 inch wide, and they came off of a lawnmower from somewhere. They were from Surplus Center, and I was actually going to do resurrect the 4-wheel drive platform that I machined all those brackets, and try to do that. There was another question. I wondered if anybody had seen any designs like that. It's kind of a modified differential. And the idea came from, it's, I guess, like a mobility device that you could actually kneel on. And, like if you did something to your lower leg or foot or ankle or something, and you could push along with one foot, and it had, I don't know, basically like a kind of a fixed T that you steered it with, handlebars on top, and then 2 wheels that with a rotating axle or pivoting axle. And I wondered if anybody had done a design like that where it's kind of differential up front with 2 fixed wheels in the back for stability. You wouldn't have a small caster, and you should be able to steer it around like you would steer this thing as you pushed it around. Granted, you couldn't. You can't do. You'd have to limit the rotation of those 2 wheels, but maybe to plus or minus 180. But it seems like you'd get kind of the best of both worlds. You wouldn't have to use a small caster or make an arrangement where you had to cut out a big hole for a larger wheel on the back of the platform. But I've never seen anybody do that, so I don't know if there's other things that you get into.
Well, I was thinking of a skid steer, otherwise there'll be 4 wheels, so there won't be any caster. But they'll the wheels on each side will be linked, so it's essentially just a wide, it's just like a tank, basically.
Right. Yeah. Anyway, I thought of maybe looking at that. And the reason why is I saw one at the Goodwill for a pretty cheap price. And I thought, I could probably tear the parts out of that thing and, use it. So, but
yeah, I mean, you should be able to spare a little time towards your platform, because you had pretty good success with your electronics. So
yeah,
you just improve on your chassis this year, and you should be in good stead.
Yeah, I was only going. Well, the motors are 22-volt motors, and I was using a 4S battery on it, and I could probably go up to, maybe a 6S to get up to the higher voltage. And, and the maximum PWM, I think I was only going like a third of the full range of speed. So it was, it was a lot, it could go a lot faster, higher battery voltage, higher PWM percentage, and should go a lot faster. But I think I'm gonna, I don't know if there's time, I may try to enter both just to see. I don't know if that kind of dilutes it and you do poorly on both, or
Tier 1.
Say that again.
Secure one of them.
Yeah.
Then hedge your bets.
Yeah. Yeah.
Secure the easiest one first.
Oh yeah. The easiest one would be the one that's already working. So.
Yeah.
But. And you've seen the 4-wheel drive platform, right?
Yeah, I think so. That's the one where you machine the pillar blocks.
Yeah.
Mm-hmm.
Yep. Kind of made my own.
Yeah, didn't that have the really big motors on it though?
It did, and at the time I didn't have additional motors. They're 12-volt automotive seat adjustment motors. So for tilting back, raising up and down, it's sometimes moving forward and back. And they have like a motorized rail on some cars, but yeah, they'll draw about 4 amps, but at the time I didn't have batteries that I could parallel up, so I could. But Megavator was 4 tons. Yeah, there you go. Anyway, so now I do have more batteries, so I could parallel. Put the batteries in parallel and not have to worry about current consumption. It could probably do it, but. As opposed to draining a battery in one round of the of the contest or something.
Mm-hmm.
So we'll see. They're 12 volt, kind of nominal 4 amp motors. Most of the stuff like that I get from Surplus Center. I could look and show you which one. Okay. I don't know if you can see that. Can you see it?
Yeah.
Yeah. Anyway, it was similar to this one. This one does not have the shaft that comes out the back. There were 2 others that did. I think if you actually look for linear actuator, it'll come up. Nope, not that one. And not that one. There's like 4 of them that, whoops.
Got you.
Were you searching Barbie?
Me? No.
Yeah.
Did Barbie pop up?
Thought so.
The Barbie movie? Yeah.
Okay, yeah, here's the ones. Yeah, so these ones actually have the motor shaft coming out the back here. So I actually put one of the 20 count Bolulu encoders on the back of the motor. And I think, let's see. Yeah, so these are like 1.5 amp no load. And I didn't use the lead screw portion of it. I just mounted the basically a fatter shaft on that, a 3/4 inch shaft, and mounted the wheels to it. But if you're going to get them, those are the ones to get, because you can it's a 1/8 basically square drive. You can take a 1/8 by 1/8 key, which is used in a lot of gears, especially with 1/2 inch shafts. And I machined that and stuck one of the Polulu magnets on the, or for the magnetic encoders from Polulu on the back of it, and there was more than enough counts from it, and based on the worm and worm gear ratio. And they rotated at a pretty good speed. I want to say it was like 76 RPMs. I don't think it says here. But, and they give the motor dimensions there, I think. Yeah, overall dimensions 6 by 2.5 by 5.5. But that's part of that is the length of the lead screw. But anyway. And the other motors were Tanner server motors that I got 4 of, and those are really nice. I haven't seen those anywhere else on any other website. So when Tanner went away, so did access to those motors.
All right. So we stay in open mic night. Where are we? Any other topics to put out there? Projects for the week?
I've got a quick question. If anybody, this might be sort of too off topic or maybe too detailed, which is, does anybody do any surface mount PCB layout with KiCad? I've got my friend gave me, he had a bunch of STM32 blue pills and black pills. That was what he standardized on about 5 years ago. Well, he got out of it and he gave me 12 of them, which is sort of a blessing and a curse because they're so rare now. All the projects that ever used them or supported them have all dried up. But I've got a project that I want to use with one, and all the parts that go along with it are all surface mount. And so I've laid out this circuit board with uses pretty much all 32 pins going out to some DRAM or SD RAM and other various surface mount stuff. So if anybody's got any experience on that, you can point me to some general advice on that. I've got it laid out. It looks like it's okay. I think at the frequencies I'll be using, it'll probably be okay. But before I waste 4 weeks waiting for the boards to come back or whatever I'd love to get some pointers on it.
I want to say there was another Paradis that seems to have the most experience with that.
It's probably my dad.
Yeah. Exactly.
Hasn't Ron Grant done some surface mount?
Yeah, I think he has. Yeah.
Is he still around?
Yeah, oh yeah. Ron's around.
Cool.
Yeah.
Oh shit.
Yeah.
I'll drop a line to Ron. Does he use KiCad? Do you know?
I think he uses Eagle.
Eagle.
He uses last time I got a copy of one of his board designs, it was an Eagle.
Yeah.
But Eagle went away, so I don't know what he's using right now.
I have access to some a Slack that's full of professional machinists and manufacturing engineers and electrical engineers, and they're all should I buy this $25,000 Altium package for my PCB layout? And I was I can't help you. I don't even know. So they're in a kind of if I were to come in there and ask a question at my skill level, I would look like a real dummy. So looking for kind of maybe more the intro level, especially KiCad, because it's not going to do any of the electromagnetic analysis and all that other heat and all that other sort of stuff that also would probably matter if I was really trying to push the envelope here, but I don't think I am. So
what about David Anderson? I don't know what he has used. Do you, Doug?
Well, the last board I had from David, he got Ron to do it for him, so I don't know.
Okay. All right.
I'm not sure.
I was I'll drop Ron a line. I haven't talked with him in I don't know 6 or 10 years. So
yeah, I'm sure he would be glad to help you out.
Yeah, he was a great guy.
Yeah.
Yeah, I don't know, Carl. What did they use at Nokia to design like cell phone stuff? Do you know?
You mean when I left in 2007? When I left R&D in 2002?
20 years ago.
Or CAD.
I remember using Mentor Graphics back at Texas Instruments, but that was on a Spark workstation, and that's the last time I've really. And then I was doing FPGAs. I mean, at those days, I was doing circuit cards with CAD designers. So there, I mean, there's a person. I'd give him a schematic, and out would come a board design. I'd sit down beside him, and yeah, it was a different time.
I don't know. You can't go wrong with MS Paint.
MS Paint and PowerPoint, baby. There, the graphics tools that last forever. All right, guys. Well, if there's nothing else for tonight, I'm going to suggest we go and dream happy dreams of outdoor robots and indoor robots and anything robots, so we get ourselves in a building spree here. All right.
See you around, guys.
Sounds good. We'll see you.
Take care, everybody.